welcome back, ladies and gentlemen. After a short break, we are entering to the second parallel session for today. We are here in technical session 5, Multihazard Risk and Governance, and Hall 1. I am Nishma Tuladar, very happy to be back again for this very session. Along with me, joining from Indonesia, we have the rapporteur, Jiten Kumar. So let's please help me in introducing the first co-chair for this very session. We have Dr. Albert Salamanca. Dr. Salamanca is a senior research fellow at the Stockholm Environment Institute Asia Center, where he leads its climate change, disasters, and development cluster. He has over 15 years of experience working on climate change, adaptation, natural resources management, conservation, development, and sustainable livelihood issues in several countries in Southeast Asia. Following, we have Mr. Sisira Madura Peruma. Mr. Madura Peruma has over 2 decades of experience in the domain of disaster risk management, climate change adaptation, and sustainable development, especially in the thematic fields of risk governance, estimation of economic and non-economic costs of climate change and disaster impacts, post-disaster damage and loss estimation, and overall institutional system development, including policy strategy and program formulation. So, technical session chair will be announcing the presentations and the respective presenters. We have 10 presentations in line. And please be noted, the pre-recorded videos will be played from AIT site itself. We will have the discussion and Q&A at the end after all 10 presentations are done. So the participants are requested to post their questions and queries in the chat box itself. I'd like to request the presenters to keep track of the chat box and answer the questions that may be directed to you. If not, we will be having a quick discussion at the end of this very discussion. So thank you so much to our co-chairs for joining all the way from different places. And now I'd like to hand over this very session to our co-chairs. Over to you, professors. Thank you very much.
Thank you very much, Nashma. So as introduced, my name is Albert Salamanca. I'll be co-chairing this session with Sisira Madura-Pinga. The session is entitled Multi-Hazard Risk and Governance. And we have 10 presentations. I think all of them are recorded. And then we will hear about different kinds of hazards. So there's going to be a presentation about saline intrusion, on cyclones, earthquakes, liquefaction, and other geologic events. And then the countries that will be covered also are India, Vietnam, Philippines, Nepal, and Pakistan. And then the presentations also will look at different kinds of knowledge. So although most of them would be around conventional Western scientific knowledge, there is at least 1 or 2 of them looking at indigenous knowledge. So it's going to be an interesting session we're going to have. So let's enjoy. But for now, I'd like to ask my co-chair to say a few words. Sisira.
Thank you, Dr. Albert. Well, it is my great pleasure joining this session as one of the co-chairs. You know, this is one of the most important technical sessions, I would say. The focus is on multi-hazard risk and governance. And when we look at the range of presentations that we are going to have today, few salient points. One is that, the focus is on multi-hazard, right? It's multi-hazard nature, not necessarily focusing on 1 or 2, but also some of the most important hazards are covered here. And the second part is that, going beyond hazard side, going beyond vulnerability side, but also focusing on comprehensive risk assessment processes in various contexts, which is quite important. And another important area is basically climate inclusive or climate sensitive risk assessment processes, going beyond traditional natural hazard related risk assessment process, but making sure that climate inclusive or climate smart risk assessment processes. And another important aspect that I like to highlight is that localizing risk assessment methodologies, making sure that the technologies, the methodologies, tools, or the processes are locally adapted or can be locally adapted for the local context so that the knowledge retention could be enhanced. And it also covers some of the areas around post-disaster damage and need assessment. But I think most important is that linking this with the overall theme of the conference or the symposium, which is disaster resilience and sustainable development. At the end of the day, I think what we all would like to see is that how these presenters or their methodologies or their findings can be linked to the disaster resilience and sustainable development, promoting the implementation of sustainable development goals, the Paris Agreement on climate change, and Sendai framework for disaster risk reduction. So we are really looking forward to all these exciting presentations. And whenever it is possible, I would request that all the colleagues, if you have any questions, please post your question in the chat box. I would also request presenters, you don't need to wait until the end of the presentation. If you like to respond then and there in the chat box, please feel free to do so, considering the time that we have limited time period during these sessions. With this, I'd like to hand over to Dr. Albert for the rest of the proceeding. Thank you.
Thank you very much, Cicera, for highlighting the key insights that one would get from all the sessions. So with that said, I'd like us to listen or to watch the first presentation, which is on multi-hazard risk assessment of educational institutes in Dehradun, Uttarakhand by Shivani Chauhan.
Myself, Shivani Chauhan, along with my co-author Aishwarya Narang and Professor Mahua Mukherjee from Center of Excellence in Disaster Mitigation and Management, IIT Roorkee, India, going to present on the topic Multi-Hazard Risk Assessment of Educational Institute of Dehradun in Uttarakhand State of India. The Himalayas are geologically active, delicate, and vulnerable to both natural and human-made disaster. Spread of irresponsible construction practices increases the risk. Schools are known as lifeline buildings as they serve as temporary shelter after disaster. In this research, Multi-Hazard Risk Assessment Survey took place at 50 schools. The study identifies the gap in construction practices in the existing school building, development trend, identify risk of school from different hazards, and recommended solution based on the key findings. The study's outcome may help to prioritize development planning decision. It can support NGOs and other groups who are working for safer school, can help to prioritize decision and budget for retrofitting execution, prepare the school for the upcoming disasters. The study area is Dehradun districts in Uttarakhand state of India, which is one of the Himalayan states that have history of disaster with huge loss of life and property every year. Dehradun district have the area of about 3,088 square kilometer with population of about 1.6 million. That makes the population density as 550 person per square kilometer. The capital of the state is Dehradun. The city lies in the Himalayan foothills between two fault lines. Dehradun is known as the hub of schools of India. There are total 1,432 government schools in the district as per 2015-16 educational data, out of which 50 schools has been surveyed for the study purpose, which consists of total 246 building blocks and 11,767 student strength. The methodology starts with site selection, school identification, and studying details about it like history of disaster, its impact, etc. Step 2 is the hazard identification, and based on that survey form was prepared. Step 3 is the multi-hazard risk assessment survey, that is data collection using mobile app. First survey is the rapid visual screening, that is seismic risk assessment of different structural components in a building like beam, column, foundation, wall, roof, etc. The second survey is the building level survey, like non-structural risk assessment and fire safety. Third survey is the campus level survey, that is to know how prone are school campus to other hazards like flood, landslide, wind, and industrial hazard. Step 4 is the data analysis and gap identification. Last step is giving risk status to each and every component in order to identify weaker point and where attention is required. The risk status is identified in 5 ways with 5 color code as shown here for better understanding and judgment. The first step is the RVS that assesses the risk of structural component in a building that performs during seismic event. It covers following 14 points as mentioned, like site condition, foundation, wall, roof, earthquake band, building geometry, openings, ponding effect, cracks, column beam, etc. Like point 5, earthquake band. Dehradun district being located at high seismic zone, earthquake band, or also known as the seismic belt, are mandatory and plays very important role. It consists of plinth band, corner band, door window band, sill band, linter band, etc. Second survey is the building level survey, like non-structural risk assessment survey that assesses the risk of non-structural component like heavy furniture, false ceiling that may fall during minor shaking or earthquake and stop the evacuation part. Fire safety audit survey assesses the risk of the fire safety readiness requirement and preparedness at each floor and building blocks. Third survey type is the campus level survey that assesses the risk of the potential identified hazard like wind, landslide, flood, and industrial. It assesses based on the past history and damage scenario of that particular hazard distant from the potential zone like nearest hill, water bodies, hazardous industry or petrol pump, etc. It also assesses how prepared our school campus to identify hazard. RVS was conducted at 246 building blocks in 50 schools on mentioned 14 points, out of which few points need very special attention, like in roof, 81% of the building blocks roof are at high risk, mostly due to dampness problem causing due to storage of water over it. In earthquake bands, most of the building blocks don't have earthquake band, thus at high to very high risk. Very few have one or two bands. In ponding effect, buildings are not maintaining required distance between them. Thus, 75% of the buildings are at very high risk. Structural and non-structural cracks were observed. Most of the building blocks are at very high risk due to column and beam condition, positioning, and failure observed like long column and eccentric connectivity. Overhang are observed not appropriate from earthquake point of views. Overall, RVS result is 23% and 9% buildings are at very high and high risk respectively and thus recommended for detailed vulnerability assessment. Result 1 is explained in previous slide. Result 2 is building level survey. Due to regional strong earthquake zonation, RVS and NSRA, that is non-structural risk assessment data, suggest high structural and non-structural vulnerability, which assume greater significance, thus recommended for DVA, that is detailed vulnerability assessment, retrofitting and fixing of non-structural element with the wall or floor. Fire, wind and flood possess a prominent moderate to high risk. Most of the buildings have fire safety equipment but not properly maintained and regularly checked. Some of the campus have trees, electrical poles in their campus, etc. that may fall even during high wind. Industry and landslide, on the other hand, possess a marginal risk. Overall attention required is shown here. Some of the failure observed during site survey are shown here, like unattached roof, sagging in the slab and beam, open electrical wiring, structural cracks, ponding effect, eccentric beam column connectivity, unattached heavy almirahs, dampness in wall, etc. The study of multi-hazard risk assessment identifies weakness in the existing construction practices in school and recommending potential prevention steps based on the findings. Several NGOs are working to make educational institute a safer place. These results will be helpful for them to utilize their budget fruitfully and in the planned way. Existing programs running by the government, semi-government, and private people are in the schools consist of retrofitting of school, refurbishment, renovation of schools, providing required services, or conducting disaster awareness program. These results can support decision maker to make a safer place for the students. Thank you.
Thank you very much, Shivani, for that interesting presentation. If you're online, there's a quick question from, I think from Loy Rego in the chat box. You can either respond to that one now or you can respond it later, but I think you're online. Okay, so the question is, do clarify and elaborate on partnership and engagement with government and in DMC, in Ministry of Education. I think that's what it means. Would you want to respond to that, Shivani? You're muted.
Sorry to interrupt, Professor. I guess it would be better if we could hold the discussion session towards the end. I guess the
Okay.
participant can make a reply via the chat as well, or else we will have a discussion at the end. Thank you.
All right. Okay, no problem. That's good. So the next presentation will be from Huy Lê on saline intrusion, vulnerability, and resilience in the Mekong River Delta, Vietnam. Case study fromIen Giang Province.
Hi everyone, my name is Tu. I will be the representative of the research team to present about our research, namely saline intrusion, vulnerability, and resilience in the Mekong River Delta, Vietnam, a case study from Dien Giang Province. Our presentation will have 4 main parts about the introduction, research methodology, research finding, and finally conclusion. The research objectives is to identify the situation of saline intrusion in Dien Giang Province and 2 districts of the research site, impacts of drought and saline intrusion, and also solution to cope with this situation. First of all, about the drought and saline intrusion in the Mekong River Delta. Since the 1990s, these areas is affected by flood with heavy rain. However, from 2012, only small flood occur and saline intrusion happens. 2016 experienced the historical drought and saline intrusion, and 2019-2020 drought and saline intrusion even more worst. So impact of the drought and saline intrusion in this region. So this region is the main agriculture area of Vietnam. However, under the impact of drought and saline intrusion, a lot of areas is affected. Nearly 80,000 households suffer from freshwater shortage, and thousands of hectares of rice and vegetation died. Our research location, we choose the Dien Giang Province, one of the province in Mekong region, and 2 districts here in the pink and the green color is that Gò Công Đông and Tân Phú Đông district is facing with a very high impact of the saline intrusion. About research methodology, we use the secondary data and primary data with key informant interview, focus group discussion, and field observation. About the research finding, first of all, about the impact of the drought and saline intrusion. This situation is a phenomenon is reduce the income of the local people because first of all, it's reduce the rice cultivation area. Many area has to switch from 3 to 2 rice crops, and also reducing the right years. The years reduced from 30 to 70%, and in some places it was completely lost, reducing the income and also increasing the irrigation cost. It's also affecting daily life of local community. Thousands of households will suffer from water shortage. They have to purchase the water with high money, and also impact on health due to the frequently staying up late at night to collect fresh water. Affecting to the environment through the salinization and landslide, because in the canal and rivers there's lack of fresh water, so risk of landslide increase. Affecting community cohesion, conflict increase due to the disputes caused by water shortage. About the response strategy, so here is the map to show the relationship among stakeholders in response to drought and saline intrusion. You can see that it's really complicated, but from our research, you can at the grassroots level, local people, like in a household, local community, and local authority, they are really lack of the skill and knowledge in response to the drought and salinization. This part we will describe more clearly in the paper. Next one is a public water pipeline. So the pipeline is installed to bring the water from the water company to the communities. However, the number of water pipelines is too small compared to the number of households, and also the water is also not stable. And the pipelines are installed on the main road, which makes it difficult for households located far from the pipeline. Community also have the freshwater filtering machine. However, we only observe one of the system in the community, and the system was used only once because it was installed at the end of the drought season of 2019. The challenges is that the cost of electricity and the change of the membranes of the system is very high. Here's a picture of freshwater filtering machine. Next one is that the pond to store water at the commune and village level. So villagers, they gather money to dig the ponds by themselves so that they can store it the water. However, the water still also very limited, so they cannot utilize effectively the ponds. About the water storage at household, so poor households, they do not have the facility to store water and also the money to buy the water, so that they have to wait for the philanthropies to provide the equipment and water storage tanks. However, for the better off and rich household, they can equip themselves with high quality and large area of water storage to purchase the water to overcome the situation. About the gender and resilience. So women are vulnerable compared to men in drought and salinization because they're mainly responsible for fetching the water. They spend a lot of time during the day to take the water. Also, they do not have enough health and transportation means to take the water, and also face with the risk of the impact on health and conflict of the community. Here is our conclusion. So the drought and salinization cause the adverse impacts on all aspects of lives of local people, from the income, livelihood, health, social cohesion, and the environment. Local authorities have effective strategies in dealing with drought and salinization. However, at the grassroots level, the capacity is still very low. Poor and near poor households and also women are vulnerable groups in the drought and salinization. Our recommendation to develop an effective communication programs to raise the awareness of the local community in the Mekong River Delta, and to develop an salinization early warning system in the 2 districts, and finally to develop a proactive model of domestic and production of water sources for the local community. Here's our reference. Thank you for listening.
Thank you very much to Lee and colleagues for that interesting presentation about drought and salinity in Vietnam. I'm sure a lot of people would have questions about the gender aspects and also with regards to recommendation on how to resolve that part of the problem. Now let's move to the next presentation by Bosco Bombali on reframing the disaster risk discourse to incorporate indigenous knowledge. So this one is not focused on a particular hazard, but looking at indigenous knowledge per se.
Hello everyone, my name is Bosco Bombali. I am a PhD candidate at the Flemish Free University of Brussels. And my PhD research focuses on integration of science and indigenous knowledge for disaster reduction. For this part of my research, I reframed the disaster risk discourse to incorporate indigenous knowledge. You might be aware that the international agenda and the global discourse is driven, first of all, by the UN strategy for disaster risk reduction, look at how top-down decisions can be trickled down into communities at risk for implementation. To make this process context-specific and people-centered, there has been arguments for incorporating indigenous knowledge. However, questions remain regarding how this indigenous knowledge fits into the dominant discourse on disaster risk and the evidence for this debate on incorporating indigenous knowledge for disaster risk reduction. So this forms the basis for my twofold objective. First, reframe the dominant agenda to fit into these debates, and also look at the evidence in practice whether indigenous knowledge is being incorporated. First is the reframing of the dominant discourse, right from the fatalistic, in which gods or deities are regarded to cause a disaster. This was challenged by the hazard paradigm, looking at science and technology for controlling the hazard processes to reduce disaster. And also, this very hazard paradigm challenged by the human behavior paradigm, where choices for people to stay in specific areas were looked at, or rather considered, to have an influence on whether a natural hazard will turn into disaster. The two, hazard and behavior, meant that there must be sufficient resources in terms of finance and techniques to be able to be implemented. And so it meant that disaster would be more prominent in less developed countries, where, for example, there are political drivers and vulnerability and economic incapacities. This same, however, was currently, I think from the 1990s, there was complexity because of climate change and other post-normal kind of situations, of course, including political drivers. And so this led to reduced certainty in trying to find solutions. This has made scholars to think of incorporating indigenous knowledge, but most of all, as for less developed communities, indigenous knowledge means that they have technologies or practices that are more adapted to the local community. So this means that indigenous knowledge is not necessarily for local communities to implement, but also that it helps to cover up the complexity brought by climate change and other post-normal situations. I look at the evidence for incorporating this indigenous knowledge based on the case of Rwenzori in Uganda, which is rather at the border of Congo and Uganda. Why do I choose this case study? First of all, in Uganda, where this case study is, the international agenda and discourse is being endorsed, where in 2010, a disaster policy and disaster risk management committees were established. And also, secondly, plenty of indigenous knowledge is being reported. So the idea is actually that, okay, having the international agenda and instituting a policy and disaster platforms in an area where there's plenty of indigenous knowledge, then it would be easily incorporated. In reality, I find that there is an equating of the disaster to a natural hazard because of the landscape and the extreme rainfall received. But the most important aspect in the second bullet here, where they talk about human choices being equated to humans actually trying to choose to stay in flood-prone areas. So in these two bullets, I look at the natural processes into which hazards turn into disaster, but also human choice. So there is the hazard paradigm and the human paradigm, but also the fact that instead of following the current discourse of actually living with the risk by incorporating indigenous knowledge, this is not the case in this case study. So I look at two other areas. For example, the discourse in the disaster management committees and platforms that I looked at, the disaster-prone areas are termed for serious reasons. First, for if they don't remove people from hazard areas, hazard-prone areas, they actually use the hazard-prone areas for capitalist motives. For example, generation of electricity that contributes to the state capitalist motives. So in general, I find that a hazard capitalist discourse is being held, and there is no kind of the discussions on how to incorporate indigenous knowledge. The question is why. For example, where the international agenda has been followed to form disaster committees, and yet they don't actually follow the same agenda to incorporate indigenous knowledge. It's not easy to answer this question, but I find two reasons why this could be the case. First of all, high technology in structural processes means indigenous practices are incapable. The second part is that there is a depoliticization of disaster risk, because following the current discourse, it would mean that policymakers would look at what is their responsibility in enabling people to go into prone areas. And then thirdly, is that the indigenous practices benefit a local economy, while actually controlling processes, the instances where there is part of the controlling, it's only on elements that support the national kind of economy at the expense of the indigenous local economy. So in a nutshell, in theory, we have the complex paradigm which can be solved by incorporating various stakeholders, including indigenous discourse and indigenous initiatives. In practice, the indigenous discourses and initiatives are excluded, and the discourse is only between policymakers and scientists. I am following up on this in my next part of the research to see what would be done, what scientists would do, and what would be recommended for the proponents of incorporating indigenous knowledge for disaster risk reduction. Thank you.
Thank you very much, Bosco, for that interesting discussion about the role of indigenous knowledge in disaster risk reduction. Now let's go back to Asia and let's look at a presentation from Bulacan in the Philippines by Ms. Lorena Hernandez on localizing climate and disaster risk assessment for selected communities in Quezon City and Angat, Bulacan.
Good day. Today I will be presenting localizing climate and disaster risk assessment for selected communities in Quezon City and Angat, Bulacan. In the past decade, the Philippines has incurred at least 463 billion peso worth of damages due to droughts and typhoons just in the agricultural sector. Over 60 million Filipinos, or 60% of the population living in the coastal areas, are directly exposed to sea level rise. The Philippines also remained within the second and third highest risk among the countries assessed by the World Risk Index from 2011 to 2018, and it only went down to the 9th highest risk in 2019 and 2020. So what is CIDRA? Climate and Disaster Risk Assessment in the Philippines is usually conducted in the municipal or provincial scale. It is used to describe and assess the risk in a specific area, and it operates on the direct connection of climate change adaptation and disaster risk management, which recognizes that climate extremes contribute to the worsening of the disaster occurrences. CIDRA also supplements decisions on development prioritization of local government units. So, the photo on the left shows the 12-step process for the comprehensive land use planning used in the Philippines, and it shows that CIDRA contributes on the 4th step, which is the analysis of the situation. So why should we localize CIDRA? Local participation in the conventional government-led planning for climate change adaptation tends to be brief, sparse, and barely recognized. Furthermore, sustainable adaptation calls for a bottom-up and place-based approach in risk assessment. The involvement of local stakeholders and acquisition of their actual experiences contributes to the responsiveness of the process to the situation in the specific community. It also builds on the principle 2 of the Sustainable Development Goals universal values and the findings of the Global Assessment Report in 2019, which mentions that no one should be left behind. This calls for inclusion for all stakeholders up to the lowest possible unit of analysis. And this is the conceptual framework of the study. The study proposes a methodology for localized CIDRA. So the process starts with gathering of the community-based data through hazard mapping activities and household surveys. The participants in the hazard mapping activity undergo capacity building activities before being tasked to draw the extent of hazard-prone areas in their community. Since this process includes actual experiences of the local stakeholders, it is identified to be their perceived hazards. For the data processing, since the hazard mapping includes digitization of community-based hazard maps, it undergoes geoprocessing. Meanwhile, the household survey includes socioeconomic data of the household and the residential structures, so a factor analysis is used to identify the underlying factors of vulnerability. The components of risk includes the indices for hazard exposure and vulnerability, and it is assessed to considering the climate projections in the specific provinces where the two community case studies belong. So climate downscaling to the community level wasn't conducted due to time and resources constraints. However, the available climate projections published by the DOST Pag-asa in the Philippines would be useful in identifying adaptation options for local development planning. For the methodology, the first step is to collect available data. The study used secondary data since the communities and their partner organizations have already completed the household survey through the open source web-based application called Kobo Toolbox, and the resulting community based on hazard maps from the workshops conducted by the partner nonprofit organizations of the two communities were also received. Finally, the climate projections mentioned previously were published by the Department of Science and Technology, the Philippine Atmospheric, Geophysical, and Astronomical Services Administration, or the DOST Pag-asa. So the step 2 and 3 goes hand in hand, which is the development of the database and the establishment of the indices. The database was stored and processed using IBM SPSS, while the results were mapped through Quantum GIS. The step 4 is the identification of the normalized risk score. The risk score used in the study is the product of the hazard, exposure, and the vulnerability indices. Each index had their own indicators. They were also weighted and normalized. The final step is the summary of the results. So this is the household risk map produced in one of the case study areas, the Masagana of Angat Homeowners Association in Angat, Bulacan. The community is located in the rural area, and the violet shape shows the hazard-prone areas identified by the community members, while the square shapes with different colors represent a household and the risk level. This risk map shows all of the hazards because none of the GPS points were located inside the hazard-prone areas. For this case, all households received the lowest possible score for the household index or for the hazard index, which is 1, while the results of their exposure and vulnerability indices varied. Meanwhile, the second photo is the residential structures risk map of the Kawan 1 Barangay Iglesia communities from Barangay Tandansora, Quezon City. This community is located in the urban area, and compared to Masagana, at least 1/3 of the residential structures were located inside the hazard-prone area. The violet shape of the map shows the geographic extent of the fire hazard, and this fire hazard was specified by the community members to be the area occupied by informal settler families. It is evident on the map that risk scores only varied to those residential structures inside the hazard-prone areas. For the findings and conclusions, the process followed for the localized HYDRA does not offer biases regarding the possible vulnerabilities. This is because it provides contextualized assessment of risk through principal component analysis, which identifies and accommodates underlying factors of vulnerability. Granular type of assessment detects the level of risk of a unit relative to the rest of the community, and an index with similar values become negligible to the overall risk score, like in the case of Masagana, wherein all the households received 1 for the hazard index, so the results of the risk score relied heavily on their exposure and vulnerability. Second, the next is the passage of the Republic Act Number 11315, or the Community-Based Monitoring System Act in the Philippines, contributes to the applicability of the localized HYDRA to be conducted in the barangay level. The results can contribute to the prioritization of local governments in disaster risk management, because propositioning of goods will be easier for local authorities and communities, since the results of the localized HYDRA will provide an overview of the situation in the community. For the recommendation, first is to add buffers to the extent of the hazards, because The study only utilized the hazard maps by the community representatives, but integrating buffers to the hazard maps is highly recommended, especially since most hazards cannot be contained on a specific area only. Use lot areas or building footprints instead of GPS for visualization and assessment because of the tendency of communities, especially in the urban areas, to be dense. And use downscaled climate projections when available. Include more characteristics of hazards and exposure, and conduct validation of the results before utilizing the data. Also get feedback from the respondents, and this will also increase their awareness about the risks that they need to mitigate. Thank you very much.
Thanks, Lorena. Interesting study. It would be insightful if you would have a chance to go back to that community and see how the finding of your studies actually aligns with the perspectives of the households that you have assessed, and see whether the way their narratives of risk aligns with what you have found. Thanks a lot. Next, let's move on to a presentation by Pradeep Goyal on the cyclonic damage assessment of rural houses for the East Coastal region of India. Again, this is an assessment framework presentation, I think.
Good morning to all of you. I am Dr. Pradeep Goyal from Delhi Techno Institute, Delhi. Today I am going to present on cyclonic damage assessment of rural houses for the East Coastal region of India. As you know that tropical cyclones are very powerful storms that cause considerable damage to life and property when they hit the coastal region. The Indian subcontinent is one of the 6 most cyclone prone in the world. Approximately 4 to 5 cyclones occur every year in the Bay of Bengal and about 1 or 2 cyclones in the Arabian Sea. The coastal states of Tamil Nadu, Andhra Pradesh, Odisha and West Bengal and some part of the Gujarat are severely affected by cyclone. A tropical cyclone is the most serious natural hazard in the coastal area in India. Worldwide attention has been focused on better disaster management program. Developing countries are more vulnerable to natural hazards than the developed countries. As such, it is not possible to prevent or control the natural hazards, but the damage can be minimized by the proper disaster management and planning. Cyclonic damage assessment of coastal region is important in relation to the wind disaster mitigation for the coastal region. Damage assessment is a 2-step process. One is hazard assessment, second is vulnerability assessment. Indian subcontinent is among the most disaster-prone area in the world. India is vulnerable to a large number of disasters, especially earthquake, floods, drought, cyclone, and landslide. Close to 5700 kilometers out of 7516 kilometers long coastline prone to cyclones and tsunami. Approximately 8% land prone to cyclones and tsunami in the Indian coastal region. The Indian Ocean, one of the 6 most cyclone regions in the world. As we can see in the map, cyclone prone in the world, more cyclone form in the Bay of Bengal than the Arabian Sea. It means the east coast is more vulnerable than the west coast. The ratio is 4:1. Buildings have been classified into 3 categories in India. One is non-injured building, second is semi-injured building, and third is injured building. Rural houses generally do not have injured building. Rural houses in coastal region of India are non-injured and semi-injured buildings. The non-injured houses are made of thatch roof with mud walls. The semi-injured houses are made of tiled roof, AC sheets with masonry walls. There are 2 quantitative methods to assess the vulnerability for a structure, namely component-based approach and direct-based approach. In component-based approach, the vulnerability of the component of a structure are determined separately, and the vulnerability of the structure is determined based on the component vulnerability and their interactions. In direct approach, the model is determined for the entire structure without considering the component, for example, by driving a relationship between historical damage and wind speeds. Rural houses in the coastal region have several vulnerable components. The most vulnerable components are opening, roof cover, second roof member, connects and walls. According to the following 5 significant basic damage modes are observed in the damage survey. 5 types of failure tends to follow some distributions. These failures are termed as component failure. If the failure of opening, roof, secondary members, connects and wall are considered as 5 distinct component failure, then 32 combinations of damage states are possible. These are the 5 vulnerable components of the similar buildings, and these are the 32 possible combinations possible from the 5 damage states. a damage. This matrix known as the damage probability matrix, and this shows the joint probability of the component failure of the component on condition on wind speed. A damage probability matrix is defined as a matrix whose elements denote the probability of failure of a damaged states considering the specific combination of components failure for a particular wind velocity. This is the procedure to how to obtain the combined probability of failure on condition of wind speed. First, the mean failure velocity of the opening, roof failure, secondary member, and connection wall failure are simulated from the assumed distribution as given in the flow chart using the mean value of your wind speed and coefficient of variation. After calculating the combined probability of failure of the components, we can calculate the damage estimation by combining the damage ratio with the conditional probability of failure of combined damage state. By using this expression, the damage can be calculated by using the equation. After combining the cyclonic wind distribution by the conditional probability of failure of component damage, then we can calculate the annual mean damage. By using the expression of the cyclonic risk for semi-engineered houses can be calculated by combining the structural fragility with the probability occurrence of the probability of wind speed. We can obtain the probability of failure of a semi-engineered house. This is the table which shows the damage probability matrix of a semi-engineered building. And these are the curve shows the probability of failure of different components: opening failure, roof cover failure, secondary roof member failure, and roof member pole connection failure, wall failure with the wind speed. This curve shows the probability of failure of component condition at a given wind speed. By combining the probability of occurrence of a cyclonic wind speed with the conditional probability of failure of component failure, we can obtain the absolute probability of failure of the different components. This curve shows the joint probability of the combined damage states. First curve shows the joint probability failure of the openings and roof. Second shows the opening, roof, and secondary member. Third shows the opening, roof member, secondary members and corrections. And last curve shows the joint probability failure of the opening, roof, secondary correction failure, and wall members. And this curve shows the annual mean damage of the semi-engineered buildings. The curve plotted between the annual mean damage and mean yearly maximum wind speed is known as the vulnerability of the houses. And this, in order to see the effect of the different distribution of cyclonic wind speed, we can take the different distribution: first Google distribution, Fazor distribution, reverse Bible distribution, 2-parameter Bible distribution, 3-parameter Bible distribution. You can see from the figure that the reverse Bible distribution has given different result than the other distributions. And in order to see the distribution, the effect on the annual mean damage, it is clear from different types of distribution we have taken. It is clear from the figure that the distributions of the probability of wind speed does not have significant effect on the annual wind damage. In order to see the effect of coefficient variation of the component failure of wind velocity, we have taken the different value of coefficient of variation 0.12, 0.2, and 0.3. So finally, we can say a procedure for obtaining the joint probability of failure of different combinations of components. Annual probability of failure, mean damage, and annual mean damage is presented using the concept of damage probability matrix. These parameters like component failure velocity of houses and their distributions and the damage ratio of components are considered in the study. These parameters depend on the region of interest. For the present study, these values are taken from the literature. The COV of the component of houses, COV, and distribution of the yearly wind speed are taken as the parametric variables. Following conclusions have been made in this study. One, distribution of the yearly maximum wind speed does not have any effect on the annual mean damage, and coefficient of variation of the component failure velocity of the component of the house, it does not have significant effect on the annual wind damage. Coefficient of variation of the cyclonic wind speed has some effect on the annual mean damage. Combined effect of the both coefficient of variation has significant on the annual mean damage. And this, thank you.
Thank you very much, Pradeep. That's quite a heavy engineering study you have there. I'm wonder what would be the sort of the governance implications of your findings. So I hope you can look at that. Anyway, let's proceed to the next presentation, which is from Mahesh Kumar on it's a study on behavior of hyperbolic cooling tower, considering the effect of soil structure interaction. Let's listen or watch that presentation now.
Good evening, one and all. Myself, Mahesh Kumar CL, working as an assistant professor in the Department of Civil Engineering, Nitya Meenakshi Institute of Technology. So today I'm here to present my topic on a study on a behavior of hyperbolic cooling tower, considering the effect of soil structure interaction. And the paper ID is DRSD 21_61. So my co-authors are Shweta KG, Shantapa BC, and Manjunatha K. So going ahead with the contents of the presentation, so I'll be explaining about the introduction, the literature review, and the objectives of the present study, and the methodology, and the results and discussions. After results and discussions, I'll be giving the conclusion remarks and references. So going ahead with the introduction, India is the 5th largest power producer in the world from the recent census took place in the 2018-19, and we come across 65% of the total power contributed from the thermal power stations. Nowadays, we can see in many thermal power plants, we can see the huge structure cooling tower. So which cooling tower is it is a very big structure. It is in our effort to save that huge structure from the dangerous earthquake data, from the danger from earthquake. A cooling tower generally it is used to reduce the temperature of a water stream by extracting the heat from the water and emitting into the atmosphere. So here in this present study, I have done I have compared the cooling tower with the fixed base to the soil structure interaction effect. So why soil structure interaction? So the term soil structure interaction has largely been used for the mechanics of the interaction between the soil media, the foundation, and the superstructure. In most of the analysis, we neglect the structure, we assume that structure is to be fixed always. But when it comes to the supporting medium, when it is a weak soil, we have to consider that soil structure interaction effect. So in the present era, the technology in advanced construction has developed to a large extent. So in that cooling tower is still is in a it is in an improving stage. So going ahead with the literature review, we have two major papers. I have done many research papers, and from that I have selected only two. Noza et al. So he has done a study on physical and material modeling of a cooling tower foundation soil system, and he has found out the response of the structure has been investigated with respect to the displacement and the stresses, and an attempt has been made to study the effect of linear and nonlinear interactive analysis, and he has done the study, and he has majorly explained about the stresses which are released in the cooling tower at the bottom ring beam and at the top ring beam using the interactive analysis of the foundation soil. And then Aman Viladkar etc. all, so they have done the study on the numerical modeling of the cooling tower using the software, SAP software, and then they have done the study using the soil structure interaction response under the symmetrical wind load acting upon it. And they found out that the radial displacements along the cooling tower shell, and they found out the design forces and the moments of the particular tower. Going ahead with after the literature review, after doing the many literatures, the research gap, I found out that is there's a scope for improvement in soil structure interaction analysis, and whenever there is a weaker soil, whether should we include the soil structure interaction effect or not. So my objective of the present study is to find out the response of the structure with the fixed base and the comparison of the cooling tower with the soil structure interaction effect. So basically, I will be doing the comparison study between the fixed base and the soil structure interaction effect. So going ahead with the methodology, we can see I have considered the two major cooling towers. One is the moderate height of 80 meter, and it has a tower as a base, throat, and top radii of 28.95, 17.2, and 17.9. Along with that, the location is, and the thickness of the shell, I have compared the thickness of the shell which I have considered is the thickness of the shell, 200 mm, 300 mm, and 500 mm, the varying thicknesses. And similarly, I have taken the highest height 190 meter. So this is the lowest height. 190 meter is the highest height, and the tower has a base and top radii is around top base top and throat radii is 65.25, 42 is the throat radii, and 43.45 is the top radii. So along with this, again, I have taken the varying thickness of 200, 300, and 500 mm. So we can find out the B value from this equation, the geometry of the hyperboloid. Since the cooling tower is an hyperboloidal equation, so hyperboloidal revolution, so that R naught square divided by A square minus Y square by B square is equal to 1. I have to use this equation, and I have to find out the unknown value B. So going ahead with the diagrams, as you can see, this is the diagram of 80 meter height, and this is the diagram of the 190 meter height pictorial diagram. As you can see, like I used columns, Raker columns over here, Raker columns over here, and the height is 80 meter, and the throat height is 64 meter. Here also the height is 190 meter, and throat height is 142.5. D throat is 34.4, and D throat is 84 meters. And now, as you can see, like model 1, I have modeled with 80 meter height and 190 meter height. I have modeled these two models in a ANSYS software, and using the IS code AS 1893/2016, I have modeled Z is equal to 0.24, impedance factor is 1.5, response reduction factor is 30. And I have considered the soil condition as to be a soft soil condition. The boundary conditions which I have assumed here is the top end is free, open, and the bottom end is fixed for a fixed case. And for your soil structure interaction, I have modeled the top end is free and the bottom end is I have connected to the Winkler soil springs. I have done the Winkler soil springs attached to it. So with respect to this, the analysis has been done in the ANSYS 18 software, and I found out the following results with respect to the two cooling towers. As you can see, like when I did the model analysis, so I found out that the frequency is high for a natural fixed base condition compared to the soil structure interaction. This is why, because of the relative stiffness of the soil, which is happening at the Winkler's approach. So CT1 we have 2.014 Hertz and 0.752 Hertz for a 200 mm thickness. For CT2 we have, this is 190 meter height, and this is our 80 meter height. This is 190 meter height with the varying thickness, and these are the values which I found out. And as you can see, like when I plot the thickness versus natural frequency graph, so this is the graph I'm getting over here, as you can see. So along with that, I found out the maximum displacement values for, I have done the response spectrum analysis using the ANSYS 18 motion software. Along with that, for both pixel based condition and the soil structure interaction effect, for varying thicknesses again, I found out that the maximum displacement values are less for a fixed based condition compared to the soil structure interaction effect. This is because of we are giving the soil spring values, and we are incorporating the soil spring values for the soil structure interaction effect. That is why the maximum displacement values are more here compared to the fixed base. So you can see the plot over here, the thickness versus the maximum displacement plot. I have drawn here CT1, CT2, and this is with respect to SSI effect. Now, after that, I have explained the maximum, and I have extracted the values of the maximum principal stress for the present response spectrum analysis for both the cooling towers. This is for the CT1 80 meter height, and this is for the 190 meter height. As you can see, like CT1 with 200 mm, I found out the maximum principal stress as 0.797 megapascals, and for soil structure interaction effect, the maximum principal stress values are less. So this is the complete plot of thickness versus the maximum principal stress. As you can see here, I have plotted CT1, CT2, and CT1 SSI and CT2 SSI. Okay. So coming ahead with the complete part, so going ahead with the conclusions, as I can say that the present work aims at comparison study of the fixed base and the soil structure interaction effect of the two natural draft cooling towers. So the conclusions arrived from this particular complete research study is the frequency for the fixed base is more. As the stiffness increases, like frequency also increases in the soil structure interaction, but because of the fixity, because of this relative stiffness, frequency is more in a fixed base. And when you compare the fixed base with the soil springs, the springs are having a relatively less stiff. So because of that, the displacement is not affected. So the displacements are more in case of the soil structure interaction compared to the fixed base. And if the soil, and we have modeled the soil properties using the Winkler's approach, which is using an elastic material. As you can see, because of that, there is an pressure which will create a non-uniform upward pressure in the foundation, and there is a leeward settlement at the structure. So with respect to this complete study, the results show that the soil structure interaction effect significantly modify the earthquake behavior of the hyperbolic cooling towers. So with respect to this, these are some of the references which I have given over here. As you can see, these are the references, some of the references which I mentioned. I thank the Second International Symposium Disaster Resilience and Sustainable Development organizing team for giving an opportunity, and I thank Dr. Indrajit Pol sir for giving me an opportunity to present my presentation. Thank you one and all.
Thank you very much, Mahesh. Maybe if you would have a chance later, if you could clarify what is the disaster risk perspective that your study is trying to link into. Next, we have a presentation by Sweta on an extensive study on damage assessment of earthquake-affected buildings in Nepal.
Very good evening to one and all. I'm Shweta KG, Assistant Professor,
Nitte Meenakshi Institute of Technology, Bangalore, Karnataka. I'm from India. My paper title is Extensive Study on Damage Assessment of Earthquake Affected Building in Nepal. So my paper ID is 63. Contents. These are my contents. Introduction followed by literature review, objectives of the present study, methodology, results and discussion, conclusions and references. So basically I focused in this particular study regarding the damage assessment. Okay, so this damage assessment is evaluation of a level of the damage or the loss caused by any event. It may be a natural or artificial or existing structure. So it evaluates the effects of the structure in terms of structural scales. So I had chosen practically in this particular study, that is, I'm going to I had analyzed I had done the detailed study or a damage assessment for the 4 buildings here. So in this particular presentation, I had just included 2 due to the time restrictions, and I'm going to explain one by one. So this is on April 25th. We all know that in 2015, earthquake has happened in Nepal that is having a magnitude of 7.8, which is measured in the Richter scale. So in Nepal, nearby Nepal, a small district called Goka, which is 85 kilometers away from the capital Kathmandu, where lot of damage have been occurred due to this severe earthquake. So I had taken this particular area as a study. So these are the literatures I had referred. So J.H. and also Valmender, they concluded this study by assessing the damage of a building and structures, which cannot give the accurate idea on the new technology building. Okay. So I majorly focused on the identification of the cause of damage due to the earthquake in terms of selection of material, or in terms of selection of the methodology or the analysis process and the design, and to find the proper way of classifying the building damages, and also to identify the appropriate grade of damage of structures. Maybe it may comes under grade 1, grade 2 or grade 3, or it may be grade 4. That we are going to analyze in this particular study, and to validate the building design by adopting earthquake resistant design of the structure as per the location or as per the zoning of that particular building, and also to suggest suitable construction techniques or methods in order to improve the resistance to earthquake, or also it can be due to the reduce the extent of the damage. Finally, to contribute to future designing construction technology and methodology with respect to the present damage on the structures. So I had gone through this methodology. The first thing is the site visit and the reconnaissance survey, and then the differentiating the types of failures in a building. Maybe it may be a structural failure or a non-structural failure, and then it is followed by differentiating the damage floor wise. What are the damage occurred in each floor that has been categorized, and then checking the state of foundation or the base, what actually it is. And then we move towards the wall failures. We check with respect to the failure of the walls. It may be a out of plane failures or in plane, or it may be a diagonal failure that we had checked in detail. And also the strength of the concrete. The strength of the concrete is checked with by using a non-destructive technique adopted here, like rebound hammer test. That kind of test we had used for checking the strength of the concrete, and also the checking the failure in the beams. It may be in a beams, or it may be in a column, or the beam column joint. We have beam column joint where actually it is that has been checked, and the failure. Checking the failure in the slab. It may be one-way slab or a two-way slab, whatever. The failure, what has occurred in the slab that has been noticed, and then checking the failure in roof, and finally
the beam column layout, and identifying a proper grade. Okay, finally, we are going to conclude this with giving a grading for that particular building, which grade it comes under, and suggesting the mitigation measures to the building. And finally, based on that particular grading value, we are going to suggest whether the existing building need to be demolished or whether the existing building need to do the retrofitting. That can be suggested based on the grading. So these are the buildings I had chosen, that is earthquake damaged building 1. This is the earthquake damaged building 1 and earthquake damaged building 2. As I told, I had chosen 4 buildings. This is damage 3 building and damage 4. Here I'm going to explain in detail with respect to this earthquake damaged building 1. Here you can observe the building has shutter in the ground floor. You can see here the building has a shutter in the ground floor, which resulting in a soft story. Okay, fine. It is soft story we can consider. So finally, I can say the stiffness of the ground floor is very less. The stiffness is very less compared to the upper floor, which is 0.8 times the stiffer of the upper story, which is very less, I can say. And for the analysis of all this building, I had chosen software called as ETAPS, and the analysis shows the results, that is the ground floor, whatever we see here, the ground floor column are overstressed. That is, I can say the column at ground floor are under designed. Whatever the column we used at the ground floor, it all comes under the under designed at the field. And the section of the column could not take the seismic loads. Whatever the cross-sectional area we had provided, that is not sufficient. So it could not take the seismic loads. And also the footing what we used in the building was under designed. So the column is under designed and also the footing is under designed in this particular building 1. And the ground floor of the building is totally collapsed. You can see the ground floor is totally collapsed, and also the building doesn't seem to be designed for the seismic zone. So this Nepal, it comes under the zone 5. When we checked, it does not comes under the zone where we have not, it has been not designed for the zone 5 region. So finally, I can assess, due to all this data what I collected, finally I can suggest that the building falls under the EDG4. What is this EDG4 is earthquake damage grade 4. So it comes under earthquake damage grade 4, which need to be demolished. When I want to say with respect to the building earthquake building 2, or one more building which I had chosen, that is building 2, here we can observe it is fully collapsed due to the earthquake. Here also due to the study I got the results like the section of the column should not take a seismic load, and also the building is not designed for the zone 5 region, and it also comes under the EDG4, so that I can say it is not, we need to demolish. Similarly, these are the results and discussions I had observed using ETAPS modeling. I had done the modeling. So this is the deflection curve of building 1 and the building 2. So finally, I would like to conclude that by doing the damage assessment, I'm going to give the grading of the scale, which varies from 1 to 4. If it is 1, it is mild. If it is 3, like that, it is major. It is in a major damage. So we need to retrofit it, or we can demolish. That can be finalized. So these are the conclusions. So thank you one and all for giving me an opportunity to share my study with you all. Thank you one and all. And if any questions, the session is open. You can ask me.
Thanks, Sweta. I can imagine that your findings would have implications on building codes. Next, we'll have Van Quang Nguyen. on site-specific ground response analysis and liquefaction assessment of Can Tho city in Vietnam. So another assessment study, but this time looking at liquefaction.
Hello everyone, my name is Quang. I am from Vinh University in Vietnam. Today I will present my studies. The title is Site-Specific Ground Response Analysis and Liquefaction Assessment of Can Tho City in Vietnam. Outline: my study includes 6 sections. First, introduction. The second, investigate soil profile. Third is input ground motions. Fourth, one-dimensional analysis. Number 5, result and recursion, and finally conclusion. First, introduction. Vietnam lies on many faults which related Indochina and South China faults, and the Can Tho city is located in South Vietnam. It's one of the 5 biggest cities in Vietnam. Population nearly 1.3 million people, report 2019. And eventually, no study has been conducted on the evaluation of ground behavior under earthquake loading. So this study aims to perform site response analysis and the liquefaction assessment. So to investigate soil profile of Can Tho city used in this study. This profile represents for cyclone C in Ô Môn district and cyclone D in Cai Răng district. So this figure presents the shear wave velocity profile for both B1 and B2. B1 means soil profile at Ô Môn district and B2 means soil profile at Cai Răng district. And this table presents the soil profile, soil property for B1 and B2 also. Input ground motion due to lack of earthquake record in Can Tho city. So the recorded ground motion was selected from the NGA Web2 database. The ground motion with flowing feature was selected. A range of the moment magnitude from 5.5 to 7, rupture distance about 1 to 85 km, and the VA30 of 760 to 1500 meters per second. After that, the ground motion was scaled to the representative second intensity level of each district. For the one-dimensional analysis, the one-dimensional nonlinear analysis was performed using the deep soil version 7. The MKZ model was used, and for the dynamic property curve, we used DRSD model 2001. Result and recursion. This figure presents PCA and shear strain along with the depth of P1 and P2 soil profile. As we can see in figure A, the PCA increased from bedrock to the surface except at the depth 2.5 to 7.5 meters. The decrease at that depth can be attributed to a larger thickness of subsoil. The surface PCA are 0.083Z for P1 and 0.073Z for P2. The shear strain can be reached 0.35% for P1 and 0.45% for P2. The maximum value shear strain occurs at the approximate position of the interface of the two soil layers, which have a significant shear wave velocity difference. So this figure presents the surface response spectrum for P1 and P2, compared with the design and average input motion. As we can be seen from here, the maximum spectral acceleration occur at period of 0.4 seconds for P1 and 0.3 seconds for P2. So based on this result, the amplification factor in node S can be calculated by the ratio of the spectral acceleration of the soil to the spectral acceleration of the rock. So H was 1.7 for P1 and 1.9 for P2. So compare with Vietnam design code, they are 1.15 for cyclet C, mean P1, and 1.35 for cyclet D, mean B2. So we can see they are very much different. Also, response spectra for cyclet C and cyclet D are proposed in blue lights. The proposed response spectra was obtained by the desired response spectra multiplied with amplification factor H. So for the liquefaction assessment, we use empirical correlation proposed by Anders and Stokos 2000. Following this method, we just need to check the liquid of the soil layer which have corrected shear wave velocity V at 1 smaller than 215 meters per second. So following our result, we just need to check the liquid of the soil layer named fill and sandy clay. So this figure showing the relationship of the cyclic stress and V at 1. So we can be seen from the figure of the result which in the no liquefaction area. So we can conclude that liquefaction intensity does not occur. The conclusion, the PGA increased from bedrock to the surface and the maximum value of PGA are 0.083 for P1 and 0.073 for P2. The maximum shear strain occurs at the boundary between two soil layers, which allow the difference in the shear wave velocity. The maximum value of shear strain are 0.35% for P1 and 0.45% for P2. The desired response spectra are proposed in this study area. The recommended amplification factor is 1.7 for P1 and 1.9 for P2. And the result demonstrates that the liquefaction intensity does not occur.
Thank you, Van. That's an interesting study on liquefaction. Next, let's go to a presentation by Muhammad Agib on the evaluation of empirical SPT blow accounts and shear wave velocity correlations using 1D site response analysis for shallow bedrock sites in Islamabad, Pakistan.
Hello everyone. My name is Muhammad Akib and I am from National University of Technology, Islamabad. Today I will be giving a short talk on the evaluation of empirical SPT and VS correlations using one-dimensional site response analysis for shallow bedrock sites in Islamabad. So my presentation will be including a slight introduction. Then I will be reviewing the Building Code of Pakistan 2007. I will be talking about the site profiles that are used in the study. Then I will be talking about the site response analysis. Then before moving on to the conclusions, I will talk about the results and discussions. So Pakistan lies in a zone of expression of collision among the Indian and Eurasian plates. And on October 8, 2005, Pakistan was hit by a deadliest of earthquakes, killing over 87,000 people. And in the picture, you can see this is the famous Margula Tower of Islamabad, Pakistan, the residential apartment, which was cut into half. And this is one of the examples of the infrastructure damage. So this, since 2005, The seismic design is, the importance of seismic design has increased many folds in Pakistan, and it is very important for us to do the site response analysis before designing an infrastructure. So for that purpose, the provisions of the Building Code of Pakistan were revised in 2007, and they were mainly based on the Uniform Building Code in UBC 1997. And the sites were classified into 5 classes, starting from hard rock towards this soft soil. And Pakistan is divided into 5 seismic zones, as you can see in the picture, from zone 1 to zone 4, and Islamabad lies in zone 2B, as it's highlighted in the box here. And the seismic design characterization is shown in the figure, which is conventionally CA and CV, the short period and long period seismic coefficients. Of course, it is old school, and we really need to improve the building code soon, and people are working on that. So this is a slide and quick review of the Building Code of Pakistan. So a number of SPT boreholes were performed. The SPT Institute testing was performed across Islamabad, and 4 representative shallow profiles were selected, as shown in the figure. The typical stratigraphy consists of fill, clay, and shell, and sandstone is usually when the weathered rock starts. So because of the lack of shear wave velocity profiles, the major shear wave velocity profiles, empirical SPTN and VS correlations were used to develop the VS profiles. The correlation of Lee et al. 1990 and Ahmed et al. 2015 are usually used to develop the VS profiles in the studies in the Pakistan related to seismic site response analysis. So we use 2 empirical correlations. The Lee et al. Correlation is a function of SPT only, whereas Ahmed et al. 2015 is a function of both SPT and the depth. So these are the results of the developed profiles. As you can see that the Lee et al. Correlation results in stiffer profiles than Ahmed et al. 2015, because Ahmed et al. Is based on both SPT and depth. So at smaller depths, it usually calculates softer VS, and as we move down, the VS increases. For site response analysis, a total of 9 input ground motions used by Sadiq et al. 2021 were used. That study was also for the shallow bedrock sites in Islamabad, and the motions were selected from the NDFS2 database. A suite of site response analysis in deep soil was performed, and the pressure-dependent MKZ model was used using the nonlinear curves of Delhi 2001. After the site response analysis, the seismic site coefficients were calculated for both sets of profiles. And as you can see in the figure here, that it is demonstrated that Ahmed et al. 2015 results in lower short period and a higher long period seismic coefficient, whereas Lee et al. Results in a higher short period and a lower long period seismic coefficients. This could be attributed because Lee et al. Results in stiffer profiles at the surface. So if you talk about the PGA profiles, the PGA usually increases as the surface is approached, and this is consistent for both sets of profiles. A trend which is common for the Ahmed et al. 2015 profiles is that a reduction in PGA is observed at the fill layer, which is attributed to a lower VS in the fill layer calculated by Ahmed et al. 2015. Then the response was calculated. The seismic design spectrum was developed using the seismic coefficients and was compared with the Building Code of Pakistan. So Lee et al. 1990 overestimates the response at short periods, whereas the long period response is underestimated. On the other hand, the design spectrum for Ahmed et al. 2015 results in a better comparison with the core spectrum. So to conclude my presentation, A suite of one-dimensional site response analyses were performed for shallow bedrock sites in Islamabad, Pakistan. Two SPT and VS correlations, widely used in Pakistan, are utilized to develop the VS profiles, and the correlation of Ahmed et al. 2015 results in a lower short period and a higher long period seismic coefficient. The comparisons demonstrate that design spectrum developed from Ahmed et al. Output results in a better match with the core spectrum in BCP 2007. Thank you very much.
Thank you very much, Muhammad Akib. The last but not least presentation, of course, is the study on the influence of site seismic dynamic response under different geological conditions by Xiao Meng.
Hello everyone, my name is Xiao Meng, a doctoral candidate from Guangzhou University, China. I'm now in Hanyang University, South Korea, conducting a joint doctoral training exchange program. Today, the topic of my speech is study on the influence of seismic dynamic response under different geotechnical conditions. In this paper, the seismic dynamic response of the actual engineering sites were analyzed on the basis of theory of seismic engineering combined with the geotechnical acceleration data in the two actual engineering. The efforts of different types of earthquakes and set geotechnical conditions on the dynamic parameters of site seismic response were discussed by using the deep soil numerical simulation software, and the site safety was analyzed. First, let me introduce the numerical simulation model. We established two different models. One is a rock layer model in Nanning, Guangxi Province, China, and the other is a CLT soft soil model in Guangzhou, Guangdong Province, China. We can learn the specific parameters of soil layer from Table 1 and Table 2. The two figures on the right are Model 1 and Model 2, respectively. Figure 1 and Figure 2 shows the acceleration time history curves of two different types of input seismic waves. The peak acceleration of Kobe wave is greater than that of Chichi wave. The Chichi wave lasts much longer than the Kobe wave. Thus, the Chichi wave can be considered as a continuous low-intensity seismic wave, while the second Kobe wave can be considered as a sudden strong earthquake. Figure 3 shows the acceleration responses calculated by the two models under the equivalent linear and nonlinear conditions of Chichi and Kobe waves. According to Figure 3, the acceleration value calculated by the equivalent linear method is greater than calculated by the nonlinear method, and the result is more inaccurate. In Model 1, the acceleration amplitude of Kobe's output wave is obviously much smaller than that of input wave, while the peak value of Chichi input wave and output wave are similar. Model 2 weakens both Chichi wave and Kobe wave. However, the weakening of Kobe wave is more serious. Figure 4 shows the surface response spectra of Model 1 and Model 2, respectively. It can be seen that when the equivalent linear calculation is adopted, the output results of the Kobe seismic wave differ greatly, and the results are not accurate. The two different sites reduce the Kobe wave more than the Chichi wave. In Model 2, due to the damping effort of the soil, the soft soil set has a more obviously weakening effort on the peak spectral acceleration. especially for the sudden strong earthquake like the Kobe wave. Figure 5 shows the variation of area's intensity with time. When the seismic waves recorded by Chichi and Kobe were input, the results show the damage degree caused by different types of seismic wave. Input is also very different in various types of sites. From the perspective of area's strength value, the soft soil site can significantly reduce the sudden strong earthquakes. In contrast, the persistent low-intensity earthquakes can dramatically reduce the site safety. We analyzed the influence of dynamic parameters on the two model profiles, the variation of the maximum displacement, maximum ground peak acceleration, and the ratio of maximum shear strength to vertical effective strength with soil depths were studied. Figure 6 shows the variation of maximum displacement of soil layer variation with depths in Model 1 and Model 2 respectively. Figure 7 shows the variation of maximum acceleration of soil layers along with depths in Model 1 and Model 2. It shows that the stiff soil layer has a more obvious dynamic response to Kobe influence, and the ground peak acceleration is larger, while the soft soil layer is less sensitive to strong earthquakes. Figure 8 shows the variation of the ratio of maximum shear strength to vertical effective strength with soil depths under different site conditions. It can be seen from the figure that the ratio of maximum shear strength to the vertical effective strength in Model 1 is greater than that in Model 2. Therefore, the influence of site conditions and the seismic wave types on earthquakes cannot be ignored. Okay. Thanks for listening. That's the end of my speech. Thanks to all the co-authors. Thank you.
Thank you very much, Meng Xiao. I think we have about 7 minutes left. I wonder whether I could invite my co-chair to offer his quick reflection on the presentations. Maybe an insight or two would help tie everything together.
Sure. Thank you so much, Dr. Albert. Well, wow, it was so exciting to see all the technical presentations about various aspects of risk assessment and their application. So I'm not going to go into each of them. Rather, giving overall reflection from my side. I would suggest that all the researchers, those who are presented today, and also all other participants, those who are attending this session, to look at also the engagement of policymakers and regulatory bodies and other related agencies in undertaking your research, because at the end of the day, what we like to see is that these research findings should be utilized for policy making processes. So engaging them at the research design itself, and maybe whenever possible during the discussion, during the findings, would be really, really good. And where possible, I would also suggest the engagement of end users. Sometimes end users could be community itself, but end users could be local governments, it could be national government, it could be insurance industries, and so on and so forth. So engagement of end users for your research would be really, really useful. And perhaps as you move forward in your career as part of academics or as part of practitioners, I think keeping that in mind would be really useful. Other important thing is basically integration of gender and diversity consideration into risk assessment processes. Some of the presentations already touch upon, but I would also suggest that other presenters, those who were highly focusing on engineering aspect of risk assessment, I would also suggest them to consider gender and diversity integration into risk assessment methodologies. And other part is basically science and practice integrations, including indigenous knowledge, is quite important. And we cannot discount the importance of indigenous knowledge and practice side into science. So I would again encourage you all to think about those aspects. And again, applications of research finding for risk financing and national budgeting processes for resilience is quite important. We do risk assessment as analytics for decision-making processes. So at the end of the day, resilience can be ensured only if resources are allocated through national budgets or other, right? So thinking beyond the research itself, but looking at the application side is quite important. And last but not least, utilization of risk analytics for enhancing and enforcing risk governance, including building codes. This was also discussed during one of the presentations. Risk governance at the end of the day is one of the most important part, right? We can do a number of research, we can do a number of presentations, unless those things are reflected in our risk governance, our policies, our enforcement mechanisms, impact might not be there. So I would suggest all the researchers and all the participants to take some of these key reflections. But with this wealth of knowledge and practices that you have shared today, I'm sure that it has enriched our discussion during this conference, focusing on disaster resilience and sustainable development. And if we can add a little bit spices around some of the points that I just mentioned, perhaps their applications uptake could be enhanced as we move forward. With this, I'd like to thank all the organizers, all the presenters, all the supportive staff, those who are part of this process. And it has been a very exciting process, almost 1.5 hours. I really thank you all. And I also like to thank our able co-chair, Dr. Albert Salamanca, and he has facilitated very well. Thank you so much. And we look forward to see you again. Thank you so much. Over to you,
Thanks,
Dr.
everyone. Good evening.
Thank you very much to such energetic co-chairs we had for this very session, technical session 5, for our parallel session 2nd for today. Thank you very much, respected co-chairs, Dr. Salamanca and Dr. Madhura Peruma, for such an engaging session. I could see the chat box as well was quite engaging, and thank you to the participants as well as thank you to the presenters for directly making the discussion and chat box such lively, and it was very interesting to see. And thank you very, very much for joining today in the technical session 5, multi-hazard risk and governance. So before we take an end to this session and ending today's long day of sessions, I would like to make some very important announcements before we end up the meeting. So as you know, we have poster presentations as well being presented in the Padlet in the networking lounge. So please do visit the networking lounge in the Padlet for your further discussions, queries. You can drop by, and actually that's the greatest place to network, to meet, to discuss. So please do drop by. And talking about tomorrow's sessions, we just a brief overview. We have a very special session tomorrow morning at 9:30 a.m. Along with that, we will be having 3 parallel sessions and 2 keynote sessions for the day tomorrow. So thank you all for joining today. We had a wonderful day. Us as the organizers as well had such a wonderful time with you all. Thank you to all the respected co-chairs. Thank you to all the presenters as well for coordinating so well. And with that, I would like to just confirm from the chair if there's anything we would like to add. So I guess with his permission, I'd like to adjourn today's very important day, the first day of the 2nd International Symposium on Disaster Resilience and Sustainable Development. Thank you.
Thank you very much.
Thank you. Thank you. Bye-bye.